In this video, I'm going to introduce the Seed Internet Emulator, just simply Seed Emulator. And this is the open source project and that we just recently released in July 2021. This project was co-founded by myself, my name is Kevin Du, and my student Hong Hao. And so we are both at Syracuse Universities. So why do we develop this? So I've been teaching cybersecurity for many, many years, and I always have this dilemma. And remember, cybersecurity is different from the other field. When we teach cybersecurity, we teach attacks all the time. If you don't understand attack, and how do you do the defense? But if you only teach the attack on paper and without getting students to work on the attack, the students are not going to get it. They're probably going to forget about it in a week or two. But if you can get them to work on that so they can have a first-hand experience on those attacks, and they're going to remember that for life. And that's what I want to do. But now you got this dilemma, right? You teach BGP, and one of the attacks of BGP is to bring down the internet. Okay, now if you get a student to do that, and you will end up proctoring your final exam in a prison. And that's not what I want to do. So that is the dilemma shared by many professors. So how do you do that? So I've been actually thinking about this for many years, and eventually we came up with this shadow internet concept. Basically, we're going to actually create another internet alongside the real internet. We call it shadow. And it's going to redirect the students, the computers, traffic, and to our shadow internet, which is emulator. Now, once the computer get into this, if they need to visit the real internet, okay, they're not going to go directly here. They were going to go to here, and their traffic is going to traverse through inside our emulator, and then eventually they're going to get into this point, and that's where the traffic go out and go to the real internet. Now, because of this, they actually do reach the real internet, and they do reach their destination. We're not hosting everything inside the shadow internet. We do let them go out, but the traffic has to go through us. And then what is the benefit of that other than delaying the traffic? The benefit is now I can attack this internet. If I want to bring down the internet, I'm just going to bring down this emulator internet. Now, once this emulator is brought down, and now you will not be able to access the real internet. So from the user experience, and you're going to see that internet is down, and the site is down. But they are not really down. It's just you want to be able to reach that, and inside the emulator. So we can actually play with a lot of interesting attack and do this, get a first-hand experience on the attack, but within the emulator. But whatever actually you do is actually similar to whatever you do in the real one. Okay, so we're not simulating the internet. We are emulating. Emulating means inside the emulators, we have machines. We have real machines. We have real networks. And we have internet exchange. So we have all the essential elements that you do have from the real internet. Okay, so when I say real, and they are virtualized, okay, they are virtual network, they are virtual nodes, they are containers. Our job becomes building the emulation and run the emulation. And these are the two parts. So when you build an emulator, and typically you're talking about these two parts, building and also conducting emulation. A lot of existing work, they focus on this part, the conducting emulation, the emulating the real world. And that is very important, especially if you do this in the industrial setting. You do want to emulate the world as accurate as possible. And that is very important. But I want to build emulator for educational use. Now, in education, you do want to actually simplify a lot of non-essential things. So you can actually focus more on the ideas, on the principles. And you're not going to be bothered with all these fancy features that we do have in the real world. So in terms of accuracy, in the education, we do not need to pursue that kind of a high degree of accuracy. Okay? We're actually trying to simplify that, but we're not going to simplify the core, the idea. Okay, so if I teach cybersecurity, I'm not going to simplify the core part. So in that one, we look at the container, Docker container. We find out the emulation conducted by the containers, they're good enough for us. So there's no need to actually reinvent the wheel and to build emulation. People spend years building the Dockers. So we're going to just use that technology. And so that actually get us to focus on helping user to build the emulator. Building the emulator is not simple. Think about, we actually create hundreds of different machines run in the emulator. Each of them needs to be configured differently. Now, how do you do that manually? That's impossible. So how do we actually help the developer to build this emulation? And that is the main focus of our project. And if you look at some of the existing work, they do have a different way to do that. And there are a way to use a graphic user interface. You have this component, you put them together, you can form internet. That's one way to do that. And there's a configuration file. You write a descriptive the way to construct your internet. That's another way to do that. And we look at some of the other successful emulation project, and we find out that using the program it is the best way to do that, because it gives you a very, very powerful tool and to construct your internet the way you want. Okay, graphic user interface approach, configuration, those descriptive language approach, they are very limited. But with the power of the programming, and you can pretty much do everything you want. That is the main focus. So we basically decide, let's just provide the SDK. We're going to write the Python class, the libraries, so the user will just use our library and to write their own Python program to construct the emulator the way they want. Once they finish that, and the program is going to generate the Docker files, and this we call the emulation file. Now, it doesn't need to be the Docker file. If you want to use a different platform and to run your emulation, and you can just generate the configuration file for that particular type of tool. So our composition part is independent from how you want to run it. Okay, so they are not tightly coupled. Currently, we only support the Docker, but in the future we're going to support other, especially the cloud environment. So you can generate the Docker file, and then you let the Docker and to run your emulation. So this is what we have in mind. Now, what kind of building block do we have? Now, we look at the internet, the technology. So we want to be able to provide all the essential elements and that we have on the internet. For example, internet exchange, autonomous systems, network, host, surveys, many other things. So for each of them, we build a class. We define the API so the user can easily use this class and then to achieve their goal. We also build the component. Now, if you think a component and think of that as integrated circuit, the element that we talked about previously, they are the transistor. That's an analogy. Okay, they are transistor, they are capacitor, and they are the primitive. Now, sometimes you build something and you want to package them together, and then so you can reuse them, and that becomes the IC, integrated circuit. We also build that. And for example, DNS, which I'm going to talk about in the next slides, and we could build actually a different kind of component. And many of the components are actually very useful for cybersecurity. But you can build components for other disciplines. My focus is more on the cybersecurity. Botnet, darknet, and we're actually building the blockchain and the component. So I can actually deploy a blockchain that consists of some number of the miners in my internet emulator. And you can do the mining, and you can then deploy the smart contract, and you can actually do the attack or just to learn how the blockchain works. And this is actually a work in progress. Once this is done, and we will be able to deploy the blockchain and inside our emulator. And this is an example of a DNS. We build actual DNS inside something like this circuit, the integrated circuit. But inside this one, they have a nodes. They have a root nodes, and they have a TLD nodes, and they have a domain nodes, domain name server. For each server, and that's we call a virtual node, so virtual. They're not binded to any infrastructure, any underlying network, and they could be plugged into different motherboard. Okay, so once you deploy that DNS infrastructure, you do need to have a motherboard. Motherboard in our case is a base layer. The base layer includes the BGP speaker, include the network, and those the hardware part. Now, when you deploy that, you just need to say, I want to connect this pin. Each pin is a virtual node. Connect this pin to this node. So basically, that name server is going to be installed on this physical node. And very, very simple. We do have a way and to make it much easier for you to bind a virtual node to the real node. Once you bind them, now your DNS infrastructure is going to be deployed on top of your the network, and they will actually function as expected. And so I do have a video, not in this one, I do have a video just to demonstrate and also show how we can build a DNS infrastructure, how we can deploy a DNS infrastructure, and we have a separate video for that. Now, in the next, I'm just going to demonstrate this overview of this emulator. As I said, we will have a series of the video and to demonstrate different features of the emulator. This one just give you a high-level overview. Now, in this one, I'm running an emulator which consists of about 63 machines. So those are the 63 nodes. These are decent size. I mean, definitely not as many as the real internet, but in terms of for mini internet, it has all the essential elements. Okay, for example, it has 34 network, 6 internet exchange in 6 different cities, and have the 13 stop net autonomous systems, 5 transit systems, autonomous system, and a mini DNS infrastructure. Okay, I'm using the 2-core in my computer, and I give it 8 GB, but you will see it doesn't use a lot of resources because we don't have a lot of traffic. Okay, it's not really just for stress testing, for performance testing. It's really for learning purpose. Now, this is the internet, the emulator that we have. So, but before I demonstrate it to you, I will just show you the whole process. Okay. The example that I'm using is called before, and you will find that in the GitHub repository under the example folder, and that's the one called B2, not B4, B2 mini internet with the DNS. Okay, so here I'm already here, and in order to compose this internet, the one that you see behind this here, in order to compose that, and I am just writing a program, and this program, I will not explain this program to you for now because I do have a video to explain how we can write that. So, but here you can just get idea. We are building this. This code is going to be just less than 100 lines of code. And now, once I finish this, I will just run this code, which is going to generate output. So I'm not going to override my current one because I have the one already. So I'm just going to put that into a different folder, output 2. And then you can just go run this one. It's going to be very quickly and just generate that. And then you can go to output 2 and you can see the folders. Those are the Docker container folder. Each one represents one container. And inside the folders, and you will see the container setup. Those are all automatically generated. And then you just do the Docker compose up. For example, not the compose up. First, you just do the Docker compose build the container, and then do the Docker compose up to start the containers. So I'm not going to do that. I have already started because the building, if it's the first time you build, it's going to take a few minutes. The second time, it's going to be very fast. Yeah, I can do the build very fast, because I have done that, the containers image are cached. So DC build is just alias for the Docker compose build in my VM. And it's going to be very fast because it's the second time, I don't know, maybe n times that I'm building this very quickly. You can see it just keep using the cached layer. Okay, now it's done. And then I will just do the Docker compose up, and that one I will sit here. And then you can also go to here in the root folder of our project, and there's one called the client. And you can just go to the client. And this one is another Docker image. And this Docker image is going to host the front end for the visualization. And similarly, just do the build the Docker image, start it, and then point your URL to here, and you will see and this one. Okay. So now we're getting here. These are the machines. They are networks. Now each of them is a container. The hexagon, and these are basically host or service, and this the circle, and those are the BGP speakers, and this is Internet Exchange. So here we have these 4 Internet speakers, and they actually connect to here, and they do have a peering relationship with one another. They are not peering among with everybody. They are peering based on their agreements with the other autonomous system. Okay. The one that connect to multiple city, like this one, the green one, this is a large the transit, and they pull the traffic from one city to another city. And this one in the real network is a national backbone, because you can see it connects to multiple cities from here, here, and here. It also connects to here. So it can connect to 4 big cities in here. So ignore the geography. I just assign this name, city name, to this Internet Exchange randomly, and then the graphic software, they actually don't have a geography knowledge, so they don't actually put the node according to the geography. So just ignore that part. And now each of them is a computer. For example, here you want to launch, get a terminal. So you can see I already have this terminal here. You can click on any node and launch the terminal. You will get a terminal. And now from there, and you can run the command. I'm going to pin another place, and you can see I can pin. Okay, so I'm going to move it here. Now, in order to visualize the traffic, you do need to set a filter. And because ping is ICMP traffic, so I'm setting the ICMP to only visualize the ICMP. And you can see here the traffic go from here and go through different city here, and then eventually go to here. Okay, that's just the basic routing. Now let's say I'm not going to peer with you. So I do have a peering here. If you look at here, let me move this closer to here, make it larger, and you can see this one peer with the AS152 here, 153 here, and this is 153. Let's just stop the peering. I'm not going to peer with you anymore. Okay. Now the traffic doesn't go anywhere. So here, once I stop peering, nobody knows how to reach you, because of 153 is a single home to stop AS. It only buys the service from one internet service provider, which is this one. If I do not provide a service to you, nobody can reach you. And that's what happened on the internet. Okay, so let's bring that back. Enable that. So here, let's see here, this autonomous system says, I'm not going to peer with you, because here it looks like the traffic is handed over to you, but I'm not going to peer with you. So I am 3 and you are 12. Let's go to here, 3 and 12. I'm going to disable this. Okay, so I am going to disable here. I am not going to peer with you. These are 2 different internet service providers. And you can see if I stop peering from here, now the traffic will actually be rerouted, and that's the nature of the internet. Okay, because there's a lot of redundancy on the internet. If you stop the link here, and the traffic will be rerouted. In this case, the traffic will be rerouted to New York City, used to be from Boston, now it's rerouted to the New York City, and then hop on this autonomous system 2, and then eventually get to here. From here, it's still given to the 12 because 2 does not peer with 153 directly, but 2 peer with 12. So traffic goes to here and eventually handed over to there. Okay. And that's just a very quick demonstration of the basic, the internet, how the internet works. And we do have a serious video and to demonstrate different features, including the DNS, including the botnet, including some of the interesting technology like the IP Anycast, how that works. Okay, so we're going to do that. So stay tuned and look at our next video.